I want to make sure you see the official UML style diagram by the Rational Corporation that sort of spearheaded this whole UML movement, probably back in the, I guess in the 90s, somewhere in there. So in my earlier recordings, I showed you a very informal inheritance diagram, which is 2 blocks with a line that says is a, and it showed the composition has a relationship with the words has a and a dash line. Then I showed you a more formal inheritance diagram where I had 3 rectangles on top of each other. The first rectangle has the class name, the second has the instance variables, the third has the method names in it. Here is a more formal, official UML style diagram. You should not have to draw any of these, but you might be asked to interpret one on the exam. So I want to make sure you see some really slight little differences here when it comes to the arrows. So all classes are represented with rectangles, so that's a no-brainer. If it's an interface, for example, it will have 2 angle brackets, the word interface, and the other 2 angle brackets in it. Now we can see is a and has a relationships here, and we can also see the relationship with the from the class to the interface. If it's an is a relationship between 2 classes, it will have a, and it's not an interface, it will have a solid line. It will have a solid line with an open arrow tip here. See that? This is parent, child, child. Good player is a player. Bad player is a player. So good player extends player. Bad player extends player. This is inheritance right here. Solid arrows going up from the child to the parent with the open arrows there. Notice that when it comes to the interface, player implements the comparable interface, and so by definition I guess good player and bad player do too, since they're children of player. Player implements the comparable interface. That is indicated by, again, the open arrow but the dashed lines. Notice the arrows go from the child to the parent, not the other way around, okay? And it goes from the class to the interface in that direction. So dashed line means this class implements the comparable interface. Solid line means good player is a child or subclass of player. Now when we have a solid arrow pointing down, that is the has a relationship, which I touched on in another recording, and it's really just a terminology thing. Refers to something we call composition. This is where one class has in it an object of another type of class. So player is a class, board and scorecards are classes. They're in rectangles, they're classes. The solid arrow is not necessarily pointing completely down, but it's not pointing up like these. Notice it's out to the side, and it's a shaded arrow tip. That means that in the player class there's an object of type board that's instantiated with probably with the keyword new, right? Board XYZ equals new board is somewhere in player. And scorecard, which is an object, is probably instantiated or created somewhere in player. Scorecard ABC equals new scorecard, is that code is somewhere in player if there's a has a relationship, which is that's what this is implying. And also here with bad player has a tutor, meaning that in bad player there's a line of code tutor Jack equals new tutor. So this object is created in bad player. It's an instance variable or somehow used in bad player. And player has a board and has a scorecard, okay? So again, they're telling you from this diagram you can see good player and bad player are subclasses of the player class. They're inherited, they're children. Each player implements the comparable interface. Each player has a board and a scorecard, but only bad player has a tutor. Okay, so in effect, we can tell a lot just from this diagram, and that's the type of thing they'll be expecting you to understand on the exam. Inheritance interface, and the fact that somewhere in player we have 2 lines of code creating board and scorecard objects. In bad player we have a line of code calling the tutor class and creating a tutor object within the bad player class. Also, if you see the term helper method, this is actually a pretty good definition, one of the better ones I've seen. What they're saying is if you have a segment of code, some task, like swapping 2 values that you are using over and over and over in a class file. So you have 5 methods and 4 of them you use the same line of code. Set A equal to B, set B equal to temp, for example. If you find yourself reusing that code over and over and writing it over and over in the class file, you're better off to pull that code out into its own method, and in this case we would call it a helper method. It's going to help the main important load carrying methods of the class with some little menial task. It's not necessarily something you would ever call from main, but you're going to call it from these other methods within the class file. So that's a helper method. So they're saying if you have a task you're doing over and over, use a helper method. That helps with readability of the code. It helps break down these big long methods into maybe more readable smaller methods. Pulling some of the code out helps with that, and we do call that procedural abstraction. So we're pulling out some code and we're putting a method call in its place in these other methods, but honestly that helps with readability sometimes when you're looking at code, so that's actually a good thing. Also, again, a very good description of encapsulation here. When we bundle methods and data fields or instance variables into a class and we make sure that everything that is in that class specifically pertains to that type of object, we call that encapsulation. So just another quick review of that term.